This is all about the
Towers of Hanoi.
Yep, the Towers of Hanoi. So let's have a look at this puzzle. This is a puzzle since the 18th century, a French mathematician. How do we get the number of discs to a destination peg, so the ones on the left, to a destination without stacking a large one on top of a small one? We're going to start off with the simplest of objectives, which is as long as the destination peg has them all stacked smallest to largest, we've reached our goal. So we're going to have a holding peg which doesn't pertain to that objective. We can stack them any old how on the holding peg. Like I said, this is not a true Tower of Hanoi, but we're going to start off very simplistically to look at the algorithm. So let's have a look at the next stage. If I can, let's have a look. Right, what does n minus 1 mean? N always represents the number in question, and this n simply means the number of discs on the peg on the left. N minus 1, therefore, in our example, means 3 discs. And that's very important. I want you to keep that in mind for how the program will work. So n is the number, origin is our original peg, where they are stacked in the right order, ascending order. Destination is where we want to end up. We want to end up with that same configuration over here. That's our destination peg, and we'll use this as a holding peg. So there we go, origin, destination and holding. Important to remember that, or we could say A, B, C. Let's move on now. As you can see in this example, we're going to use our holding peg to hold 3 discs. Do you remember n, which is 4, minus 1, so move n minus 1 discs to our holding peg. Then move the remaining number of discs to our destination, and now we can obey the law or the rule to not ever overlay a larger disc over a smaller disc on our destination peg. We've broken the rule here, but like I said, the objective is purely to get it one larger than the other first on our destination peg. So what do we have to do now? We just have to reset, and once again n minus 3 on our holding to our destination. So we've completed that particular task. But let's look at how you would write the algorithm. First of all, always state where you are starting. We're starting with n equals 4, 1, 2, 3, 4 discs, and of course for annotation purposes d equals disc. So start at origin O. Move n minus 1 discs from O to H. Move n discs from O to D. Move n minus 1 discs from H to D. And let's see what those numbers actually entail. So it's 3 discs from origin to holding, leaving us with 1 disc, which is going to go from origin to destination. And now we look at our holding peg and we move the remaining 3 discs from H to D. And that's the simplistic version of the Towers of Hanoi. Your most important thing to remember with regards to this is the way we annotate, because that's going to dictate how easily and efficiently we write our algorithm. Now we can turn this into pseudocode, and now we can use this in a console application. So that's the Towers of Hanoi. And the next step is to look at the function, how we would turn this into a function or a method for a program. So for example, our pseudocode will say, let's call it move disks to destination tower. That's the name of our module. And if the number equals 1, then move disk, origin, comma, destination, else move tower n minus 1, origin, holding, destination. And that's our program. And we'll look at that as a VB console application.